Hello friends, in this video I'll show you how to apply the cauchy integral formula and we will solve some integrations involving complex numbers by using cauchy integral formula. So first of all, the cauchy integral formula is a very easy concept, so don't panic if you don't understand on the first go. The cauchy integral formula states that if a function fz is analytic within the simple contour C, and if z0 is any point interior to C, then the integration of fz upon z minus z0 dz along the closed contour C is simply given by 2 pi I into f of z0. This is the first form, and the second form is the integration of fz upon z minus z0 raised to n dz is simply 2 pi I upon n minus 1 factorial f of n minus 1 z0. So we will solve some examples now based on the first form. Later in the next video we will solve examples based on the second form. So let us go to the first example. So the first example is integration of e raised to z upon z minus 1 dz along the closed contour C, where C is mod of z equal to 2. So now first we have to find out what is z0, what is f of z, and what is the contour, how the contour looks like. So on comparing, we can see that z0 is 1, f of z is e raised to z, and the contour is a circle. I'll show you how I concluded that it is a circle. So first of all, we noted down that z0 here is 1, f of z is e raised to z, and the contour z mod z equal to 2 implies that we can write z is equal to x plus iy. So on putting this in the contour equation, we get x plus iy mod equal to 2. So now on applying the modulus function for complex numbers, we get x squared plus y squared is equal to 2 square. Now this is the formula of a circle. Now here the center is at 0, 0, and the radius is simply 2. Now we'll have to draw the contour on the argand plane. So the x-axis represents real part and the y-axis represents imaginary part. So on drawing the contour, center at 0, 0, radius 2, 0, and now we'll find out whether the z0 lies inside the contour or outside. Now 1, 0, z0 is 1, which is simply 1, 0, which lies inside the contour. So this is the very essential part. We can only apply Cauchy integral formula when the z0 lies inside the contour. If there is no z0 inside the contour, then the integration simply equals 0. That is the thing you have to keep in mind. So now we have z01, f of z e raised to z. So the answer according to the Cauchy integral formula is simply 2 pi I f of z0, which is equal to 2 pi I f of z is e raised to z, and putting z0 in this function gives us e raised to 1, which is simply 2 pi I e. And this was a very simple example. Now we will come to a complicated one. This example will further clear your concepts. So here we have to perform the integration of z plus 2 upon z minus 1 z minus 3 dz, where c, the contour z minus 1 mod, is equal to 1. So now we'll have to find out how the contour is. So putting z equal to x plus iota y in this equation, we get x plus iota y minus 1 mod is equal to 1, which implies x minus 1 whole square plus y whole square is equal to 1 whole square, which implies this is again a circle's equation, which is centered at 1, 0 and radius is 1. So drawing it again on the argand plane, centered at 1, 0, I'm sorry, I'll just draw it again. Radius is 1, which gives this point is 2, 0, 0. Now here are two z0s, one is 1 and other is 3. Now which one lies inside the contour? We see that 1, 0 lies inside and not 3, 0. So here there is only z0, one z0, that is 1. The other one lies outside, so it is not a z0. It is a part of the function fz. So now what is fz? So we can further write it in a clever way like this. Z plus 2 upon z minus 3 upon z minus 1 dz. If we multiply this numerator by into 1 upon z minus 1, which gives us this only. So now the function f of z is z plus 2 upon z minus 3, and the z0 is 1. So now putting the now applying the Cauchy integral formula, we know the answer is 2 pi I into f of z0, and f of z is this. So putting z0 in this, we get f of z0 equals to f of 1, that is 1 plus 2 is 3 upon 1 minus 3 is minus 2. So that is minus 3 upon 2. So now putting this value in the answer, we get 2 pi I into minus 3 by 2, that is simply minus 3 pi I by 2, and into 2, so the 2 gets cut, is minus 3 pi I is the answer. So we'll do one more example in the next tutorial, which is a more complicated one involving two z0s, both of which lie inside the contour, and then we will go for an example based on the second form. So please stay tuned.